John, our friend. So, a couple of things I wanted to mention that or one thing that I neglected to mention is that we have a free creche at this conference. And we've had it every year, even actually before PyCon UK, but we've had it for 4 years running here at City Hall. And we've always struggled to get children in it. So it's disappointing to pay for it and to offer it, and then to find out that it remains empty and that the people running it might as well go home because no one's brought their children with them. But I'm really pleased that this year we've had a big jump in the usage of the creche. So yesterday in particular, it was pretty full all day. It's been occupied all day. We'd really be pleased if you were to come back next year with a child of your own to put into the creche. Yeah? I think probably it would be going too far to borrow someone else's child just to put it in the creche. But what you could also do is let other people know that here is a Python conference that has a free creche for your child. Because we know that many people, or parents as they're sometimes known, find it difficult to attend things like this because they've got to look after small children. And of course that burden always falls disproportionately upon their mothers. And since one of the things that we're trying to do in this event is to have a more diverse range of attendees, and that includes bringing more women into the conference and into computing and programming, we feel that the creche is one of the ways in which we'd like to do that. So if you know people or parents or specifically mothers who might be interested in coming to a conference like this, but don't because the difficulties of arranging childcare gets in the way, please let them know about it. Please mention it on Twitter, especially if you've got a big Twitter clout. That would be helpful. We'd appreciate that. Thank you. And speaking of small children's, I'd like to mention Mark Hawkins, our photographer, who wasn't here yesterday because he's just had one of his own. So congratulations, Mark. There he is. Mark, if you ever have childcare issues next year, I'll let you know about a place where you can bring your child. So to let you know what's happening for the rest of today, don't forget manual technology and board games in the lower hall at 7:30. There'll be a pizza van, a good one, Italian one, that I chose, outside in attendance, and that we'll have the bar as well. If you're going to the Clink tonight, I know that 27 of you are, you need to be there at 18:45, 6:45. That means you leave here at 6:15 in the company of your leader, Ian Oswald. Ian, are you here? Look, there's Ian standing on a chair, so you can follow Ian to the Clink tonight. And now I think we're all ready for the lightning talks, aren't we? Lightning talks, let's go.
Okay, let's go. Let's get this thing started. Okay. Welcome to the second session of the PyCon UK Lightning Talks. Ben, can we get you to the stage? Awesome. And Nicole, you're next. So, I have some reminders, because not everybody who is here today was here yesterday, so for those people who weren't here, or people who might have forgotten within 24 hours, you have 5 responsibilities. So if I am talking and somebody behind me is and bear in mind they're behind me, if they're ready to go, could you just kind of point at me? As long as I get a handful of people doing that, that's good. He's not ready. Ah, now he's ready. I'm still going. There's 4 more things. So if I start to tap my fingers together like this, I want everybody in the room to follow along. It's a weird noise. It indicates to the speaker that they have about 2 sentences to wrap up before everybody starts to go wild and claps and whoops and stamps. Can we try all those? Woo! That's brilliant. You were also enthusiastic yesterday. If we can keep that up today, that would be fantastic. Take it away, Ben.
Thank you. So I wanted to tell you about why I run my own Python package repository. So I do this regularly, pip install numpy. So what happens when you type that in, hit enter, it browses PyPy, looks for a wheel with a matching platform tag for your platform. If one is found, it downloads it and installs it really quick. If no match is found, you have to fall back to building from source. So what happens is it goes up to PyPy and says, yeah, what kind of x86 are you? I have all of them. And these are all the different combinations of wheels available for different platforms, different Python versions for NumPy. And I'm like, actually, I'm Linux on v7L. It's like, what? Never heard of it. Here's the source. Build it yourself. Takes about 20 minutes to install that on a Pi 3, the latest Raspberry Pi, and about 2.5 hours on the original Raspberry Pi. So it takes a long time to get that. And if NumPy is a dependency of the thing you're trying to get, you have to sit through all of them. So I thought, well, fine, I'll build my own package repository. So if you type PiWheels and then the package name, you get a wheel file, so tagged with Linux on v7L. And I'm like, well, I kind of want that, but for all packages. And there's 175,000 packages on PyPy. I'm like, well, I kind of want that, but for all versions of all packages. And that's 1.2 million package versions. I'm like, well, I kind of want that for Python 3.4 and 3.5, the two versions of Python 3 that are on the Raspbian releases. So yeah, I sort of built some tooling to automate doing that. Now you're probably thinking, I assume you cross-compile. Nope. I built them all on natively on real Raspberry Pis. There is a cloud service provided by Mythic Beasts, a hosting company. They have a rack full of Raspberry Pi 3s, and you can just hire them out. And so the stack that runs this service, which I call PiWheels, there's a master that distributes jobs to the builders. So there's one Pi hosting all of the wheel files in the web server and managing what jobs and what packages need to be built. There's also another Pi running a Postgres database that monitors PyPy, generates the build queue, works out what needs to be built next, logs all build attempts and logs what happens when builds fail and things like that. And it also logs all the downloads, so we know which packages are getting installed and which ones are being used most. And then the builders, which we can scale up and down. So we originally, just to clear the backlog, given the entire something like 1.2 million package versions that were out there, trying to build through all of those. I did it on about 20 of them on this Pi server. It was really easy to just provision them all and get them all sitting there working through the build queue. Then once we finish the backlog, we just need to keep up with new releases. So we have 3 on Raspbian Jessie, has Python 3.4, 2 Raspbian Stretch with 3.5. But then the database got kind of a bit big and running out of RAM a lot of the time, so we switched that out for a real server. But the whole thing, the rest of it runs on Pis. So how to use PiWheels. So Raspbian Stretch is now pre-configured to use PiWheels.org as an additional index to PyPy. And users get platform wheels without knowing that it's there. So they pip install NumPy and it just comes really quick without them having to do any configuration. So any tutorials that were written before this that say, go and go for a walk for a couple of hours and come back and see if it's finished, it just sort of takes a few seconds now and you can carry on with what you were doing. We also have official support for TensorFlow on the Raspberry Pi. So you can pip install TensorFlow because Google provides, they build their own actually, they're not automated because they don't provide source distribution, but they provide us with platform wheels for Pi, which are also built on the same Cloud Pi platform. So we just import those and have those in the system as well. PiWheels is getting quite heavily used. It's shipping, the one Raspberry Pi that's running the web server is shipping nearly 500,000 downloads a month. There are pushing nearly a million wheels on the system as well now. And we worked out that we've saved a total of 23 years of build time in the 10 months that it's been running. So if you want to read more and look at the GitHub and things like that, check out PiWheels.org for more info.
Thank you. So can we get Nicole to the stage? You got Nicole? Thank you. Can we get the other Lightning Talk speakers towards the front? There's actually an empty area over here, which might work. Some seats over here. And after Nicole, we've got Celine. Can Celine kind of stick up her hands? Perfect. So, yeah. I was so excited to get... Oh. No, not quite ready. So I was so excited to get on stage, I nearly knocked over 2 things on the way up and then nearly tripped over the steps. So I need to calm down a little bit. Take it away, Nicole.
Okay, hi. So I'm Nicole, and I would like to talk to you about enabling yourself to grow, and yourself and others, really. But before I do, I need to do a bit of a disclaimer. Most of what I'm talking about is not my ideas. So a lot of it comes from Carol Dweck. She's a psychologist, and she's amazing. The link up there is to one of her TED Talks. You should watch it. It's really good. The second person is Deborah Searle. She's a rower. And she's a motivational speaker, and she's really, really inspirational. So I basically just nicked their ideas. I would like to start with fixed versus growth mindset. And this is best explained when you think about how people react to not succeeding. There's 2 types of people. There's one kind that goes like, well, my intelligence is up for judgment, and I have failed. And this is a pretty harsh way to react to something. Then there is the other type of person, the growth mindset type of person, that really believes that they can improve. And they believe that they just haven't succeeded yet. And that makes a massive difference between how people really live their lives. There's been a really interesting study done between high school students where this concept was introduced to them. And basically they've been told, once your brain is out of your comfort zone, the neurons start forming new, stronger connections, and you are literally becoming smarter. Now, once students thought about it, it turned out that working hard doesn't mean that you're stupid. It means that you're literally getting smarter, and that changes perception so much. This had incredible results. Chronically underperforming schools have all of a sudden, within a year, managed to get towards the top scores within the whole country. And what I also found interesting was that there was a study of brains of people who have the fixed mindset and who have the growth mindset. And the people with growth mindset, if you present them with a challenging problem, the brain just lights up. It's like a Christmas tree. It's just, there's so much going on. Well, people with the fixed mindset, they're not even focused on the problem. There's almost nothing going on because they're just escaping the problem. No wonder they're not going to make any progress. And from there, I'm thinking about choosing your attitude. And that's where I come to Deborah Searle. Deborah, as I mentioned, is a rower. And she has entered a competition to row across the Atlantic with her husband as a team. Now, if you ask me, this is incredibly impressive on its own already. But what happened was that her husband, as they sort of managed to get into the middle of the Atlantic, realized he has a crippling anxiety of the open ocean. And so they're there sitting in the middle of the open ocean, and he cannot do anything. So they called the rescue team. He stopped the competition, and he went back. However, Deborah didn't. She remained on her own, and she was the only woman in this competition, mind you. She remained on her own on this boat for over 100 days. And she's just so incredibly positive about the whole experience, the way she described it. And it wasn't easy for her. She had days where she woke up and she was feeling incredibly miserable. And what I found really funny was that at some point she saw a turtle that went faster than her boat. And she just felt so bad about that. But throughout this whole time, she tried to keep a positive attitude. And she asked herself questions such as what if I was in a really good mood today? What would happen? And then she would think well, if I was in a really good mood, I might row harder. I might go faster. My day might get faster. I might arrive at my goal quicker. And that, in turn, brought her into good mood. So it was kind of like a self-fulfilling prophecy. She got herself to a good mood by thinking about what would happen if she was in a good mood. And eventually, this paid off, and she arrived to Barbados much, much later than everyone else. But it was an incredible achievement. And well, what does that mean for all of us? What can we extrapolate from all these amazing people? I would say being harsh on yourself when you don't succeed is very counterproductive. It's something I'm guilty of myself, and honestly, it hinders growth, and it's something we should change. Just be kind to yourself and be kind to other people. Secondly, we should, as a society, we should start praising effort and journey, not results. I know results are important, and we all agree on that, but at the same time, we're not building the growth mindset. And this is especially important for young children. We really need them to think the way that if they're working hard, it's a good thing. It doesn't mean they're stupid. And lastly, I would like all of you to just think about, do you have a growth mindset? Because it's something we should all aim to acquire, I think. And I'm just going to leave you with a slightly cheesy, but I think really good quote. Whether you think you can or you can't, you're right.
Woo! Thank you, Nicole. So, Celine, if you'd like to set up. Next is Qasim, who's sitting over there. Excellent. So, who's been learning new stuff today? Sounds like you've been literally becoming smarter just by sitting in the room listening to some things that you didn't understand. Okay.
Hello, everyone. So good to see so many people here. It is interesting talking about the growth mindset because I'm going to talk about some things which are related to sometimes getting out of your fears and taking risks. So for those who don't know me, my name is Celine. Right now, I'm a team lead in software, lead the Code for Life project. We had a workshop this morning and yesterday. I also used to be an app developer in a robotics company back in France, where I learned my first Python concept. There are also a lot of things that now, as an adult, I really like doing. So some of my current hobbies are writing, drawing, alternative modeling, fashion blogging, parkour, modeling, yoga, and trying to find time to sleep and failing. But I used to be a little kid. This is a picture of me when I was about 9 or 10. Now there are things that we tell kids, and that is a good message, trying to encourage kids to do what they want, especially, for instance, for programming. Like if they want to learn how to program, they can do it. It's a very important message. Now, that's what I've been trying to do as well, to live my dreams, but I guess I'm also actually trying to live my nightmares. And getting outside of my fears and trying to do things now which I used to be really scared about. So this is quite a very cheesy image of my idea of hell when I was 12-year-old, to give you such an idea. So the ocean is because I am still a bit afraid of putting my head underwater, but I've got a friend teaching me how to swim, and I managed to swim last week. Also, thank you. Also, I'm afraid of snakes, but I'm trying to override that by programming in Python and wearing skates. Yes, I also used to be afraid of cemeteries and skeletons, which is why I became a goth. Also, I was afraid of doing any sort of sports because I was always the last one being picked at school in the teams when they were created, which is linked to something else, which is a bit of a heavy topic for me, but I used to be bullied quite a lot during most of my childhood, actually, for what I used to wear, what I used to look like, etc. So I was also afraid of that and of being in the spotlight. So basically anything I would do, I would not put outside in the world because I was afraid there was a risk of me becoming famous or appearing on YouTube or whatever, and then people bullying me for that. And that was even Twitter, even before Twitter existed, so you know. Yes, so just afraid of things like that. Which is why now I've got actually a fashion blog. And I can say that I'm now probably an alternative model as well because I got contacted on Instagram by a photographer and it's someone I don't know, so it's quite interesting. Yeah, so yeah, obviously shameless self-promotion. If you go on the links there, you can see some of my pictures, and it's quite geeky because I also talk about GitHub and Markov chains in my fashion articles. So if you're interested, and so for me, it's quite like putting me out there, right? So it's quite a big step, trying not to be afraid of that and trying not to care anymore, basically. And something else that I really enjoy doing is parkour. I actually started in January, and it's something I've always wanted to try. But as I said, I was not a big sports person. I only started sport when I was 27 or 28 with yoga. I used to think that my back was not in a good shape enough for me to do stuff like that. I'm also afraid of, falling, like most people are. But most people think that parkour is just crazy stuff. So on the left is a picture of Simon Nogueira, which is amazing, but you have to understand he trained for 15 years, 10 years, but I think he was 10 when he started, so you can imagine. And if we can see, if we can see this video. This is the sort of things that people, I can hear the in the room. But to go there, you have to train for it. So this is on the right, it's much less impressive. It's a picture of me back in January. I didn't have my blue hair, but I was just sort of awkwardly jumping off a wall. So it doesn't look as impressive, but that's actually how you start. So you have to really train from the basics. So this is Parkour Generations. So they have like a gym in London, but if you go on parkour.uk, it's the UK parkour actually official website. You can find like other gyms and other trainings, because obviously it's also a lot of outdoor trainings. And they really try to teach you from the ground until you can build enough strength or confidence. So actually I don't do a lot of impressive things right now, but it's, as we said before, actually it's a journey, right? So it's really important to build all those skills. So actually, Parkour Generations are responsible for having parkour as an official sport in the UK. So it's the newest sport that have been added as an official sport. And it's the only country, even if it started in France, my country. Parkour is different than freerun. Parkour is supposed to be going from A to B in the most efficient way, even if that means jumping on walls, etc. And freerun is sort of the same techniques, but with more acrobatics and more exploring your environment freely. And Parkour Generation gives trainings on all those aspects. So I won't be able to sort of parkour my way out because I've got a dress, but if you're interested, we can talk more about it later. So yeah, for me, it's really all of that is a way to proving to myself that I can do things. So I can't, do like the flag on the, I can't do the flag on a rooftop like Simon, but I'm still doing much more things than I thought I was capable of. This journey is important, and I choose not to live my life in fear anymore. So I hope that whatever you want to do in your life, you can have the same attitude. And thank you very much.
Thank you, Celine. So, Qasim, if you'd like to set up. And after Qasim, we have Hannah, things you can't 3D print.
Test.
Okay. So your microphone's working. No slides?
No slides.
Okay, take it away, Qasim.
Hello, my name's Qasim. Just call me Q. And I fell in love with Python about 10 years ago. However, despite using Python, sometimes you just have a bit of work that's mind-bogglingly boring. And you have to somehow cope with this. Now, I want to distinguish mind-bogglingly boring work from boring code. There was a talk about boring code, and I think that's probably a good idea. Boring work, on the other hand, I don't like. Or, well, it can be a bit dangerous. People might start introducing apostrophes into the middle of variable names and start thinking about how they can add emojis or ASCII art into there as well. People around me tend to start getting pranked. Everyone except for me, strangely enough. And it just goes downhill from there. I once worked on like a package or a module, and there was a lot of boring work to be done over the period of about a year. And I had a little strategy for surviving that, which basically involved refactoring that code. But now you might say, but Q, now I've got two problems. Firstly, it's still boring work, and now I've got a headache as well. This strategy is useful because all code everywhere always needs refactoring. I've never encountered any code that did not need refactoring. But the secret trick is to introduce a little feature or a new capability that you want to see. So you're introducing some of your vision. And this engages your brain, so now the work becomes interesting. There's two problems that you might encounter. And as is typical, they are problems that come from other people, never you. The first problem is that other people reviewing your code might start saying, the code that you're making is a bit complicated. It's adding in abstractions that you might not need, and there's features and there's code in there that doesn't seem to be doing much. So the solution to that problem is to have absolutely massive pull requests, just massive amounts of refactoring, just dump it onto them, and inside there just hide in that little bit of capability that you wanted to see. So the second problem that you might encounter is when other people are working on that module or that package, they do the work that's in the ticket, and that's fine, but they take 2 steps backwards in your secret vision that you're introducing for this package that you happen to not tell anyone about. So the solution to that problem is to plant your feet firmly on the ground, stop them from doing that work by leaping onto any tickets that come up that relate to that package. This is a win for everyone involved. It's a win for the business. You can, I don't know, make up an excuse as to how that works. Maybe what you're introducing is already in the backlog somewhere, or maybe your productivity is actually the same overall because now you're doing interesting stuff. It's a win for your coworkers because you're picking up that boring work that they don't want to pick up. So secretly, they're thankful. And also secretly, they're probably thinking you're a bit crazy for doing this. And it's a win for yourself because that boring work has now become interesting. So while you might have expected me to say that when you're doing some boring work, you should talk with people, say that it's boring, discuss and collaborate, maybe talk about the new features that you want to introduce, share your feelings like a mature, responsible adult, but that's not what I'm saying at all. You do the exact opposite. Keep it a secret and introduce your feature over the period of an entire year without anyone realizing, so that at the end of the year, bit by bit, with all that hard work that you put in, you can say to everyone, with this one line of code, we can introduce this brand new feature. And that's the little cherry at the end of the year. Thank you.
Thank you, Q. So I think Hannah's just about ready to go. After Hannah, we have Jake. Can I have a hand up? Awesome. Why can't these computers just work out what you want? Take it away, Hannah.
Hello. My name is Hannah, and I'm going to talk to you about stuff that you can't 3D print. I've been interested in 3D printing since before I was a student, and now that I work in the industry, I get a lot of questions about what 3D printing is capable of. So I'd like to introduce you to the hype cycle. This is the Gartner hype cycle, which tracks the introduction of a new technology. So you can see that when the technology is introduced, we have the technology trigger, and then people quickly become more and more aware of it until it reaches a peak of inflated expectations, which is where 3D printing is right about now. Then, as people get accustomed to the technology and what it can actually do, they fall into the trough of disillusionment. They get really disappointed that it can't do the things that they wanted, until finally, once they've gotten used to it, they ascend the slope of enlightenment to the plateau of productivity, where they can actually use the technology for things that they want to do. So yes, 3D printing, firmly at the top of the peak of inflated expectations at the moment. So what is 3D printing? It encompasses a whole bunch of different technologies. Mostly when people talk about 3D printing, they are thinking about FDM, which is fused deposition modeling. That's when you take a plastic filament, you melt it, and then you deposit it in lines to build up structures. That's what you'll find in desktop 3D printers like Ultimakers or MakerBots. So what can't you make with desktop 3D printing? You probably can't make a Lego Death Star. I know. The throughput of 3D printing is just not high enough to make tons and tons of pieces, like all the Lego pieces that you would need to make a Lego Death Star. People have the idea that if you have a 3D printer at home, you don't need to go out and buy anything ever again because you can just print everything that you need. Unfortunately, that's not the case. They're pretty slow. If you've ever 3D printed a part, it usually takes hours to make a single pretty small thing. That's true even of the more sophisticated industrial 3D printing machines. They're not the fastest. These are some molding machines at Lego's factory in Billund in Denmark. They have a throughput of around 36,000 Lego pieces every single hour. So yeah, your desktop printer is not going to compete with that anytime soon. This is a study from a firm called Sculptio, which is a 3D printing bureau. They compared the cost of making this remote control part 3D printed or making it through conventional injection molding. And they worked out that once you get to around 500 units, you stop seeing benefits from 3D printing. It actually becomes less expensive to mold the part instead. So it's not really suitable for huge production runs of stuff, more individual things, like this companion cube. Another thing that people are really worried about is 3D printing guns. Fortunately, this isn't too much of a problem. Some guys at the University of Warwick did testing of a 3D printed gun, the most sophisticated model available, and found that the results were pretty unimpressive. They ranged from small failure to complete catastrophic failure. When attempting to fire the weapons, more often they would just explode rather than deliver any kind of projectile force. So I wouldn't worry too much about 3D printed guns anytime soon. People also think that you can 3D print living things, like maybe a kitten. I would love to 3D print a kitten. Sadly, this isn't the case yet. I'm holding my breath. However, this is Luc Masella. He was given a life-changing operation in 2004 where cells from his bladder were implanted onto a 3D printed scaffold to regrow a bladder for him, and then that bladder was implanted in his body. And he's still doing great. He hasn't needed to have any other operations for his bladder. It's still going. So bioprinting organs is a really exciting possibility that's actually happening right now. There are folks working on it actively, and I can't remember their names, but one of the recent Nobel Prizes related to bioprinting. If you're super keen to find out more about 3D printing stuff, I wrote a paper recently, which is about case studies in where additive manufacturing is awesome, with a particular focus on medical applications. I work for a company called GrabCAD, which has an online community, kind of like Thingiverse, but for mechanical engineers to share their 3D printed parts. Yay.
Woo! Thank you, Hannah. So we need Jake to come to the front.
Let's see if this works.
Jake, are you Jake?
I am.
See, I can't count. That's my problem. Amy's next. Awesome, thank you. I've so far managed not to buy myself a 3D printer. I have been informed that it is the kind of thing that will just take up space in our house. That's almost certainly true.
Hey! Okay. Why did that vanish?
See, this is a trick. This background is beautiful.
Hey! There we go.
There we go. Okay, take it away, Jay.
Everything's broken. Right. That'll do. Wow, there's a lot of people here. So many faces. My name's Jake Howard. I'm a software engineer for a company called DabApps in Brighton. I do backend engineering and DevOps wizardry. But I'm not here to talk about me. I'm here to talk about Student Robotics, which is a charity which, as it says, enables exciting robotics challenges for teams of young people. So just a quick show of hands, who has heard of Student Robotics before? That's more people than I was expecting, to be honest, and one person I already know, so that's fine. Because he told me about Student Robotics, that's fine. I'm glad there's more than one hand, that's something. So for those of you who don't know what Student Robotics is a UK charity that run an annual competition for college students between the ages of 16 and 18 to design, build, and develop purely autonomous robots to compete against each other. The competition generally runs over 6 months between October and mid-April, culminating in a weekend-long competition. Before anyone thinks, is this just Robot Wars? It is not Robot Wars. Student Robotics is a strictly non-contact competition. Take from that what you will. I tried to get them to change their minds. Health and safety is really annoying. So what we provide to teams is a kit. This is comprised of 3 proprietary built, fully open source, both in software and in hardware, boards developed internally. We have a motor controller, a servo controller, and a power board. The kits are provided to schools for free to build their robots, and their schools are also given a small contribution to build the rest of the robot, to do like woodwork, Meccano, things like that. Alongside building the robots, obviously, they have to develop their robots. And naturally, this being a Python convention, this is done in Python. The unfortunate thing is, it's Python 2.
Ooh.
You share my opinion, that's fine. We're working on that, apparently. These robots, as I said, they have to be completely autonomous. The only input is one start button. They press the start button, the robot goes, that's it. So to give an example, last year's competition, which was back in April 2017, because reasons, was called Easy as ABC. There were 9 tokens in the middle of the arena, 3 of different colors, and teams had to bring them back to their starting zone. Different colored tokens were different numbers of points. With 4 robots, you can somewhat imagine the mayhem. And you don't actually have to imagine, I can show you some of it. So yeah, that's just a screen photo of an arena with robots doing various different things. This one not being completely flat. So Student Robotics is run entirely by a crack team of volunteers who give their free time for free to help run these events each year. The next one we will be running will be competition number 11, so we've been doing this a while. Teams get the opportunity to build some very interesting things with help from people in industry like me to other passionate robotics enthusiasts. Some teams go with some very safe ideas. Some teams go somewhat crazy with this multi-tier laser-printed wood thing. And one team built a spider. This has 8 individually controlled legs built with purely servos, and if you're an arachnophobe, I'm very, very, very sorry, I think. So, why am I here? Mainly publicity. We need volunteers, mentors, teams, sponsors, and just generally good press to help grow Student Robotics to accommodate more teams, cooler kits, and even bigger venues. If you want to volunteer and help, like me and I know one other person in this room does, I think, then you can visit our website to sign up. If you work at a college, have a child in a college, or have generally any other connection to a college that might be interested in doing something like this, you click on the other button on our website. So the website to sign up to is studentrobotics.org. There's a QR code there, because everyone here seems to love QR codes, so let's keep that pattern running. If you want to find out more, I'm here until Monday. Come find me and talk about robots, because I enjoy talking about robots. For any other longer-term questions, there's an email address down there that gets to me personally. Ta-da!
Woo! Thank you, Jake. So, Amy, if you can get set up. Davey, good Davey, awesome. Everybody's in the right place. It's fantastic. Makes my life so much easier.
Thank you.
Every time I see what younger people are doing with computers these days, I start to panic about the rest of my career.
Oh, that's helpful. Okay. Right. Okay. Right. Hello. My name's Amy, and today I'm going to be talking to you about how I got InDesign to do Python syntax highlighting for me. One question you might have, first of all, is what is InDesign? So InDesign is a piece of software by Adobe that is typically used by graphic designers who are laying out a document to be published. So whether that's a coding resource or a book or a magazine, it's kind of used for those sort of things. A little bit about who I am. I'm currently a design engineering student at Imperial College, and design engineering is quite a new topic, so basically it's learning how to make things, because I was highly indecisive and couldn't decide between computer science or electronics, so this way I get to do a little bit of everything. I'm quite a firm believer in the kind of interdisciplinary projects, and I think that this is a good example of one of those. So a couple of weeks ago, I was involved with creating a booklet for a festival you might have heard of called EMF, or Electromagnetic Field. EMF is a conference/festival in a field for nerds, and there's Wi-Fi, there's internet to your, there's power and internet to your tent, and every time it comes around, there's a very elaborate badge, and this year the badge was running MicroPython. The badge had run MicroPython, the EMF, before, but I'd found that resources around it were a little bit scarce, and I wanted to create a more accessible way to helping people get into using the badge. The trouble was that the code that was required for running the badge was a little bit work in progress, so I wanted a way that I could put the code into the booklet layout and be able to modify it later. So I didn't really want to be taking screenshots of a text editor and be having to completely update them. So I took to Google to work out if InDesign could do it for me. I came across this comment, somebody in a similar position to me, on the Stack Exchange for graphic design, and somebody suggested that you could use grep styling to do it. I wasn't sure what grep styling was, so I looked into it a little bit more, and basically it's like a fancier version of find and replace, or find and format in this case. So I found a very handy cheat sheet and set about working out what rules I needed. And so the first step was to set up a paragraph style called Python, and then it kind of involved a lot of me squinting at Sublime Text to try and work out what rules I needed to do, and squinting at the cheat sheet to work out how to do that. So these are the rules that I came up with. I won't go through them. Some of them are more complicated than others. One thing that was weird that I came across was that, so the way that the grep works is it looks through a line of code, through a line in a document, and you can check what the characters are behind and what the characters are in front. But there's two different ways for looking behind, and when I needed to change the color for a function name, one of the look behinds worked, but the other one didn't, which was highly confusing and a source of lots of frustration. But I want to demonstrate to you how satisfying this is now. So this is what it would look like when you first get it into InDesign. Oops, that's a bit small. But now if I click on paragraph styles over here, let me zoom in a little bit. So this is the not Python paragraph style, and this is the Python paragraph style. And if I double click on here and into the grep style, these are all the different rules that were written. So you can apply this to other programming languages too. If you use InDesign and you think this would be useful, I can send you the file so you don't have to write all the rules yourself. And this is it in context for the badge team. It turned out to be incredibly useful and not a waste of my time, because some of the code was changed at the last minute. And you can type in live, so if I type in a comment, then it will automatically do all the colors and things, and if I make a string, then it does all the nice coloring for me. So, thank you for your time.
Thank you, Amy. Woo! So, Davey, if you'd like to set up. Martin, you're next. I have that leaflet. I was at EMF.
It's on the wrong side.
It's so good when you meet somebody who did something that you used. Oh, okay. Public service announcement. It is just about 6:15, so anybody who's going to the Clink should head out the door about now. I won't take it personally. Come back tomorrow.
How do I mirror? I don't appear to be able to. I can't mirror, so this will be a feat in pointer movement.
Oh.
Nope.
Okay.
Apologies. So, pretty bold statement there. Split the audience straight off. But let's get a little bit more specific. Analogies aren't bad. Bad analogies are bad. That's not a very helpful statement. So let's go a little bit more. For an analogy to be useful, it needs to be a couple of things. It needs to reference a very familiar concept or model, and we need to be able to map objects in that concept or model to the domains under question. And there are some problems with that. We have to make assumptions about familiarity with that concept or model, and those may not always be correct, especially when dealing with diverse audiences that you're trying to explain something to. Mapping those objects takes a little bit of mental energy, and it also introduces a source of ambiguity. So, when we're trying to explain a complex thing, in the face of this increased complexity, we reach for analogies that illustrate a bigger picture or impart a high-level understanding. And that's good, but a poorly chosen analogy will hinder understanding. As an example, typing a URL into a browser is like sending a letter asking to see a website. That makes some sense, but it can really confuse people who are learning about how the internet works for the first time. The post system is familiar to most people. Assumption, is it? It has a huge number of moving parts that must be attributed to parts of the internet that, in order to make your analogy make sense, and it means throwing a whole lot of new words that fit together into a schema that isn't really what you want. For example, letters, envelopes, addresses, stamps, URLs, DNS resolution, requests, responses. How do these map to each other? Is that clear? Is it not? Should I spend time explaining how those map to each other in order for my analogy to be useful? Or maybe have I over-engineered this explanation? But there are many good, wrong analogies. Analogies aren't bad in and of themselves. For example, a variable is like a box that holds data. Variables aren't boxes, they don't hold data, they refer to it. That is an important distinction when you are learning about the internals of a language, but it's not something you need to know when you're learning about assignment operation for the very first time. So, to close, don't force an analogy in order to force understanding. Try to just use simple words to explain the thing, and you'll probably do better. Thank you.
Excuse me, I'm slowly dying on stage here. So Martin, if you'd like to set up. And next we've got Joe. Can I have that? Yep. I really am dying. This is terrible. You have no idea how many drugs I'm taking just to stand up right now. Okay.
Please be seated.
I think we have time for, if people really stick to the time and if every setup goes okay, we should have 3 more talks, I think.
My clicker.
Oh, thank you very much.
Yeah, it's already not showing.
Quick round of applause for Martin, please.
All right. So who's afraid of Stack Overflow, right? I'm a community moderator at Stack Overflow and a frequent answerer. I answer lots of questions, but lots of people think of that frequent Stack Overflow as trolls. They don't want to ask questions because they think they're going to get shut down. That's because a lot of people think Stack Overflow is a help desk, actually. You post a question, you immediately get an answer from helpful volunteers. That's what a lot of people see it like. It's not actually quite a help desk. Stack Overflow wants to collect knowledge. It wants to make it easily accessible. So if it wants to make forums where you ask code questions obsolete, and it wants to do so that other people can find the answers that have been provided in the past. So it's not a forum either. It's not something you go into and post a question that's very broad about what kind of stack you should be using to develop your website. You want to ask focused questions. The format doesn't fit a broader format. It doesn't fit recommendation questions. So on the whole, if you don't understand that kind of thing, you might have a bad experience. But if you want to ask a question, you have a question you want it answered, usually the answer is already there. You just have to search for a little bit. So focus on search, and then on asking. Google is your friend. But when you do your research, try and keep track of what you've found and what you tried, because it's helpful later on. Because if you do eventually ask a question and someone says, sorry, it's duplicate, then you already know why. People will actually have seen what you have found before and can make a much better determination if it is a duplicate and what post might help you and might solve your problem. And it's fine, because terminology is hard. You can always get the right terms in there for it. Maybe you don't know that something is called a pickle or marshalling or things like that. And you have to ask a question in different terminology. But other people may have the same question and use the same terminology you used. So now your duplicate post is actually helpful because it helps other people find the canonical post. It helps them find the path to the answers. And when you do post a question, make sure to include an example. If you have code and it breaks, show us, please. See if you can focus it down to something small. You know, troubleshooting is always about narrowing it down to a specific point in your problem. So bring it down to a smaller problem by removing the code that doesn't actually cause the issue. If there's an error, it's a traceback, please do include it. The full thing, not just the little message at the bottom, not the exception. Give us the traceback because it tells us how Python got to the problem in the first place. What things it did in the past to get there, what the context is. Make sure you test that little snippet. Open up a new Python interpreter or a new file, paste it in there, try it out. You would be amazed at how many people don't do that. They think they've narrowed it down to the problem and they post just a little bit, and that part works. And they don't understand later on why people are a little giving that feedback that actually this is not the problem. And that research you found earlier, the pages you saw, include those. Tell us about it. It doesn't have to be a whole list, but just say, when I searched this, I found these kinds of posts, and they didn't help me because of these things. That helps people understand what your problem is much better, because they see, okay, it's not that thing that I thought it might be. And when you post those kind of things, you generally will get answers quite fast, quite quickly. And you'll get upvotes too. And that will be a much better experience.
Thank you. So, Joe, if you'd like to set up. And next we have Johnny, who I think is probably going to be our last speaker of the day. So I think we had to discard about somewhere between half and 2/3 of the cards that we got today. So we got a whole load of submissions. If you weren't chosen, please put in a card again tomorrow. Oh, okay. Apparently this one's complicated. Somebody's suggesting I should tell a joke about tractors. Oh, more mild laughing than groaning. I'm surprised. I have some shorter jokes. It turns out one of my colleagues has been doing exactly the same thing as me today at a Mozilla conference. But he's been telling bad jokes. So I wrote down the two that I like best. What does a proud computer call their child? A microchip off the old block. Those are the noises I wanted to hear. What's another name for a computer virus? A terminal illness. I'll stop now. This is why I don't tell jokes on stage. Those are the kinds of things I find funny.
Okay.
Right. You ready to go?
Hello? Yes. Hello. I'm Joe, and I work for one of the sponsors of PyCon, Pico Technology. We make oscilloscopes, which are those massive things that you remember that sit on a bench and have a little green trace sat on the front, except that now they're only this big. And you plug them into your computer and use your computer as a screen. And I'm going to show you a trace on a screen, hopefully using Python and an open source wrapper for our drivers. I do have another piece of hardware in the complicated mass of wires, which is about $15 on Alibaba, and I'm afraid I can't tell you who made it. But what it does is spits out a sine wave. So we're going to try and see the sine wave. Okay. Here is a Python script. This is, let me make that smaller. There we go. This is using the API which I have spent the last 6 months or so making as a wrapper for the drivers. We had one before, and it was written by somebody who didn't know Python, and it wasn't very good. I hope this one is better. And what I'm going to do is just run it rather than sit here and explain code to you, because that's boring. So. Okay. There we are. And we can see a sine wave. Now, this is a NumPy array of data, which is being rendered with pyplot, matplotlib, which means that we have this little zoom button. So we can zoom in and see, is that a bit blocky? Because this is only an 8-bit oscilloscope, and yeah, look, you can really see the height of the bits there. That's not very good. We want a better definition sine wave, so I'm going to close that, and we'll run it again. So now, this is an oscilloscope which is 8-bit, but you can be really clever, and you can reduce your precision in the time dimension to give you more precision in the voltage dimension. So I'm going to do that now by typing in a magic number, and I'm saying make it 9 bits rather than 8 bits. And we should see a slightly prettier sine wave. Does it look a bit prettier? Let's have a look. Yeah, it's slightly prettier. Okay. Last demonstration, I'm going to just stretch the bounds of information theory, and I'm going to use 9.3 bits, which is the prettiest trace that this device can do, I think. And there we go. Slightly prettier again. Because my company is sponsoring PyCon, I have a giveaway. So basically, this device here, I'm giving to the coolest hardware project that I see, because you need to be able to use oscilloscopes to debug your hardware projects, obviously. So if you are doing a hardware project here, come and find me, and the coolest one wins. I'm here until Tuesday.
Thank you, Joe.
There you go. Thank you.
So while Johnny sets up, can I just get, half the speakers this evening have been first-time speakers, and it definitely takes, it's a step out of your comfort zone, and we had a talk about that, to stand on stage and talk to an audience that maybe you don't know that well. So can we have an enormous round of applause for our first-time speakers? Thank you very much.
Praise God. Yeah,
It's always a good sign.
It's almost worked. Oh, please, where's my settings gone? I've lost the settings. Oh.
It's full screen.
Yeah, no.
I don't have any more jokes.
I'm not sure what's happened. Oh, I wonder if I move...
I'm not going to tell the tractor joke.
This. Oh, Jesus. I've lost my mouse. If I drag it to there, is that? No, I've got to drag it up
It's the same,
or
but
left.
slightly darker.
Oh, I was on the screen. Let go. Okay, this'll... Well, this is going to be fun. I can't quite see what I've got up there, so... But we'll give it a go. So welcome to Karma Pi. I'm Johnny Gill, and I'm going to talk about... Karma Pi is a personal project of mine. By the way, the Gill bit, it's 2 L's, not to be confused with the Global Interpreter Lock, and I'm pleasantly surprised that nobody's giving a talk about a Gillectomy this Python conference, because I've run across a few of them over the years. So, first round object, this is Guido's clock, and since it's a lightning talk, we better set it to, that didn't work, 5 minutes to midnight, so I'll give myself 5 minutes for the talk. Again, that's Johnny Gill, Karma Pi. If you want the code, it's on GitHub under SWFIUA, which I can explain what that's about if anybody wants to know, and Karma Pi. So it actually, this particular application we're looking at now, I was living in Bermuda at the time, and this is actually a download of one of the images from the Bermuda weather radar during Hurricane Nicole. And I wrote this little utility that I'm using to present this talk, originally to download these and display these images. But what I realized actually, it's quite a good tool. If you arrange images in folders by year, month, day, there's a lot of data that works really well for to navigate through. And so that's one of the themes in Karma Pi. One of the goals was very much, I have the last 20 years I've been working in catastrophe modeling with a particular interest in hurricanes and tropical storms. And one of the original goals with Karma Pi was to start creating better climate models, but it's suffered a bit of scope creep. Another type of round object, and I'll show this running in a bit. I have at times I run into periods where I really can't motivate myself to write code. The Karma Pi's got a lot of sort of 40 or 50 modules where I explore things that I'm interested in until I find out they're 100 times harder than I thought they were, and then I move on to something else. One of the things I do to motivate myself is write code about things I'm really interested in. So when the World Cup was on, I wrote a little simulator. I had all sorts of wonderful plans for them. And in fact, this project is nearly 4 years ahead of time, because it's almost finished for the next, all I have to do is change the data for the next World Cup. And this is an early screenshot from a buggy run of the simulator where England actually managed to win the World Cup. So, I just pressed the wrong button. One thing about the Karma Pi, it's not working for me. Yeah, it's popped the help. That's annoying. I'll get rid of that. Oh, Jesus. Sorry, it's popped the help. Helpfully put the help on the other screen. And now I've lost my pointer. Can anyone see my mouse? Got it. Hang on, lost it. Right. Click, escape, back to, and now I have to get my mouse back over here, I think. Tell me when it goes on the screen.
It's in the middle.
Okay, click. Right, perfect. Next slide. The other problem that I'm particularly interested in, this is actually the main motivation of the project, is dealing with this particular problem that we're suffering from, which is the globe warming up. There's a lot of really great data available, what we call climate reanalysis data, where you can get global grids of data, a 0.75 degree lat long grid, which gives you the daily temperature at 2 meter height for every day since 1980, as produced by the latest numerical weather models. So one of my goals here is to try and fit Markov models to this data so we can project it into the future. So you get a model that will just capture the Markovity in the process. In some sense, it's unopinionated, and it's a good baseline. I was working in the reinsurance industry, and the models they use are not adequately capturing the climate change factors that are going on. They're tuning to the past and assuming that the future will be like the past, and that's a little bit of a dangerous assumption right now. What else have we got? Finally, in Karma Pi, there's some cosmology. I came across it last October. I went, for my sins, I studied mathematics at Warwick University back in the 80s. And Colin Rourke was actually my tutor, so when I saw he'd produced a book on cosmology, I was kind of interested to read it. So here's the book. This is Colin. He actually looked like that in 1980 with the big beard and everything. Wonderful guy. I actually saw him a couple of days ago. And I've been trying to code up some of the mathematics in his book. It's an absolutely phenomenal piece of work, this, but he's been working on it for 20 years, and I haven't got time here to go into it, but if anybody's interested in cosmology, I'd love to talk with you about what's going on here. It's fascinating. So without more ado, it's running a little bit fast, this one, and I think the screen resolution isn't work, but if I rerun it, you can see the sort of World Cup going on. What I did with this, I just had the teams moving between the various locations in Russia and so on, and I was going to do all sorts of simulations that take into account the distances that teams were traveling and put in factors for whether the Russians might be interfering with that team, given the venue and stuff like that. To be honest, when the World Cup was on, I spent most of my time typing in the goals and the yellow cards. So also in Karma Pi, there is a small data set that you can work with. Now then, next widget. And this here is the cosmology.
Time.
We're done.
Thank you very much, Johnny. And thank you very much to all our speakers this evening. Big whooping, stamping, round of applause for all our speakers. Some might say, like this glass of water, we are halfway through the lightning talks for this year's conference, but some might say that we have 2 more sessions to go. So please submit talks tomorrow, please submit talks the next day, and I will see you at 5:30 tomorrow. Thank you, everybody.
Thank you very much, Mark. Thank you to all our lightning talk speakers. Thank you to all the speakers, presenters today, everyone who's helped. Thank you to the audience. Thank you, everyone. In not long now, in an hour's time, less than an hour's time, we've got manual technology and board games downstairs in the lower hall, plus pizza. Thank you very much. See you tonight or see you tomorrow.